In this program, you'll look at the most common methods of preparing a steel surface for painting and examine their advantages and limitations. Surface preparation is the most important single factor in coating performance. There are a variety of surface preparation methods, each one having its own advantages and limitations. Determining which method is most appropriate for a job depends on the location of the job, the types and amount of contaminants on the surface, the original condition of the steel to be painted, and local safety, health, and environmental laws. In addition, each paint system has its own specifications for surface cleanliness and surface profile. These must be followed to avoid premature paint failure. You can learn about the degrees of cleanliness and how to measure surface profile in other parts of this series. The most common methods of surface preparation are hand and power tool cleaning, solvent or chemical washing, steam cleaning, high-pressure water blasting, wet blasting, abrasive air blasting. Hand tool cleaning is one of the oldest methods for preparing a surface for coating application. Because it's a slow operation, it's generally used if the job is small or inaccessible to power tools, or when power-operated equipment is unavailable. It is useful for removing loose paint, thick layers of loose rust, dried soil, and other loosely adhered foreign matter. It will not remove tightly adhered contaminants, foreign matter lodged in pits or crevices, or oil and grease. Scrapers, chipping hammers, sledgehammers, chisels, and knives are commonly used hand tools. They remove layers of rust by impact. When you use these tools, you must be careful not to dent or puncture the surface, or to raise burrs which will interfere with the adhesion of the paint. Air and moisture will collect in the dents and form rust. Hand tool cleaning is a limited method. It does not adequately prepare new steel surfaces for paints which require a very clean surface. The variety of hand tools available for surface preparation is duplicated in power-driven equipment. Power tools fall into three basic categories: impact cleaning tools, rotary cleaning tools, rotary impact cleaning tools. Chipping and scaling hammers and needle guns are impact cleaning tools. These types of tools are useful for removing heavy deposits of rust scale, mill scale, old thick paint, weld flux, slag, and other brittle materials. Needle guns and similar power impact tools are particularly suitable for small, difficult-to-get-at areas such as bolts, rivet heads, and pipe flanges. As with hand tools, you must take great care not to make any heavy indentations into the metal surface. Rotary power tools do most hand cleaning jobs rapidly. Wire brushes and sanding discs are two types of rotary power tools. They're used for preparing welded surfaces and heat-damaged areas. They are also commonly used to remove paint, which has been loosened or lifted by rust that has formed under the paint film. Rotary impact tools operate on the same basic principle as other impact tools by cutting or chipping. But rotary tools use centrifugal force to throw the cutters and hammers against the surface. A rotary chipper can be advantageous on large areas to remove rust and scale. All power tools tend to polish the surface if used improperly. Therefore, you should avoid using them at too high a speed or on one spot for too long. A polished surface is a poor anchor for paint. Power tools cannot remove all rust and scale. They're generally used for removing loose rust and scale and for special touch-up work. And like hand cleaning tools, power tools do not leave a suitable surface profile for high-performance coatings. In solvent or chemical washing, the metal surface is wiped with cloths soaked in chemicals. This method is most effective for removing oil and grease from limited areas and for occasional cleaning prior to painting. Since the solvent rapidly becomes contaminated, fresh solvent must be used constantly and the rags turned and replaced. The last wash must be made with clean solvent to avoid a film residue which could interfere with paint bonding. Because solvent washing has no effect on rust or mill scale, You should use it only as a pre-treatment before mechanically cleaning areas contaminated with both oil and rust or mill scale. Steam cleaning is generally employed to remove dirt and grime on top of existing paint. Wet steam under elevated temperatures and high velocity is effective on heavy soil and in areas where solvent wiping would be difficult. On rusted or abraded areas, steam cleaning is usually followed by spot blasting or wire brushing. Often commercial detergents are added to improve the quality of cleaning. High-pressure water blasting, or hydroblasting, is a method that uses water at high pressure, 10,000 psi, and low volume, 2 to 15 gallons per minute, to remove loose, flaky rust and mill scale on hard-to-clean surfaces. Injecting the water stream with sufficient abrasives makes the process much more effective. When high-pressure water blasting is used with abrasives to clean to bare metal, a second washing procedure, which includes a rust inhibitor that is compatible with the paint to be used, must follow. Its limitations include uneven cleaning and flash rusting. For maintenance cleaning, high-pressure water blasting provides a high production rate if a surface profile is not required. However, when a surface profile is required, wet blasting is a much more efficient method than high-pressure water blasting. Wet blasting, instead of abrasives being injected into a stream of water, water is injected into a stream of air and abrasives. Wet blasting is much more productive than high-pressure water blasting when a surface profile is desired. You can also use wet blasting to wet down a surface in order to control dust, and with only minor adjustments to dry off a surface. When steel must be totally clean and fully exposed, abrasive air blasting is the recommended method. Proper abrasive blasting provides a foundation for the paint system, resulting in a clean surface and a uniform profile. In abrasive air blasting, small, hard particles such as shot or grit are directed at a surface with great force through an air hose and nozzle. A compressed air stream gives the speed to the abrasive particles. The impact of the abrasives completely removes rust, mill scale, and old paint, along with a bit of the base metal, until a firm, clean surface results. It is the speed of the abrasives that is the working force. The surface profile is obtained by the force of the abrasives striking the metal surface. Abrasive air blasting is the most common method of steel surface preparation used to remove intact mill scale, rust, paint, and other contaminants. However, it is not effective for removing oil or grease. High-performance protective coatings demand a controlled roughness or surface profile, as well as a high degree of surface cleanliness. Abrasive air blasting is the only method of surface preparation which can completely remove tightly adhering contaminants and provide the surface profile necessary for good paint adhesion. Since each paint system has its own requirements as to the depth of surface profile and degree of cleanliness required for the paint to adhere properly, it is vitally important that you follow the specifications set for each job you do. In this program, you have examined 6 methods of preparing a steel surface for paint application: hand and power tool cleaning, solvent washing, steam cleaning, high-pressure water blasting, wet blasting, and abrasive air blasting. You saw where each of these methods is most effective and where their uses are limited. Remember, you should use the method that is most appropriate for the job, as it is determined by the job specifications and your supervisor.